Hey everyone, and welcome. Today, we are diving into the absolutely amazing world of waves. Seriously, from the light that lets you see me to the sound of my voice, waves are literally everywhere. And trust me, once you get how they work, you start to see the whole universe a little differently.
Okay, to get us started, I want you to picture something. You're standing next to a pond, and the water is perfectly still. Now, you take a little pebble and toss it right into the middle. So what happens? You see those ripples spreading out in perfect circles, right? We've all seen it. But what is actually going on there? That simple question is going to be our launching point for today.
So, to really get to the bottom of what's happening with those ripples, let's be super clear about what we're going to achieve today.
By the time we're done here, you're going to be able to do three key things. First, you'll be able to define exactly what a wave is. Second, you'll know the difference between the two main types. We're talking transverse and longitudinal waves. And third, you'll be able to name some real-world examples for each. Sound good? All right, let's jump in.
All right, first things first, let's tackle that mystery of the pond ripples. We need to figure out what is a wave really. So here's the official definition. A wave is a disturbance that travels through something and it carries energy. But here's the part you really got to lock in. It does this without transporting objects. This is so important.
And that leads us to the single most crucial point of this whole explainer. Waves transfer energy, not matter. This is a huge misconception for a lot of people, so let's nail this down. Think back to our pond. Those little water molecules, they're not taking a trip across the pond with the ripple. Nope, they're pretty much just bobbing up and down in the same spot. It's the energy from that pebble hitting the water, that's what's traveling outwards.
Okay, now that we know what a wave is, it's an energy mover, let's meet our first of two main types. This is the transverse wave, and you can think of this as the up and down wave.
And here is a perfect way to picture it. Imagine a boat just floating out on the ocean. A big wave comes rolling toward the shore. What does the boat do? It doesn't surf all the way to the beach with the wave, right? Of course not. It just bobs up, and then it bobs down, pretty much in the same spot. That's because the water particles are moving up and down, which is perpendicular, or at a right angle, to the direction the wave's energy is traveling.
So let me ask you a question then. If the water and the boat are just bobbing up and down, what is actually moving towards the shore? Think about it for a second. You got it. It's the energy. The energy is what's making that journey to the beach, while the water itself just hangs out and moves up and down. Now, let's break down the anatomy of this wave. Transverse waves have two main parts you need to know. The very highest point of the wave is called the crest, just like the crest of a mountain. And the lowest point it dips to is called the trough. Easy enough, right? Crests are the peaks and troughs are the valleys.
And where can you find these in the real world? Well, obviously, the water waves we've been talking about are a perfect example. But get this, light waves are also transverse waves. And even certain types of earthquake waves, called S waves, move in this up and down way.
All right, time to meet our second main type of wave. If transverse waves were all about moving up and down, longitudinal waves are all about moving back and forth. Think of it like a push and pull.
Okay, so this one's a little different. Here's how it works. It starts with a vibration that pushes particles forward. This causes them to get all bunched and squished together in an area we call a compression. Then, as the energy moves along, those particles spread back out into an area called a rarefaction. And you just get this repeating pattern, compression, rarefaction, compression, rarefaction. And here's the most important part. The particles are wiggling back and forth in the same direction that the energy is traveling. They're moving parallel to the energy.
Now, what's the number one everyday example of this? Sound. Think about it. The sound of my voice right now. It's hitting your ears as a longitudinal wave. My vocal cords are vibrating, creating those little compressions and rarefactions in the air that travel all the way to you. How cool is that?
Okay, so we've met our two types of waves. Now, let's do my favorite part. We're going to put them side by side to really make the differences stick in our brains.
This chart makes it super clear. Let's look at particle motion. For a transverse wave, it's perpendicular, up and down. For a longitudinal wave, it's parallel, back and forth. What about their key parts? Well, transverse waves have those high points, crests, and low points, troughs. While longitudinal waves have the squished up parts, compressions, and the spread out parts, rarefactions. And for our go-to examples, it's easy. Light for transverse and sound for longitudinal.
All right, you all have done a fantastic job. Let's do a super quick recap of the absolute must-know points from everything we've covered.
Okay, if you remember nothing else from today, please remember these 3 things. Number 1, waves move energy, not stuff. That is huge. Number 2, transverse waves move up and down, perpendicular to the energy's direction. Just think of that boat on the ocean. And number 3, longitudinal waves move back and forth, parallel to the energy's direction. Just think of a sound wave. If you've got those 3 points down, you have totally nailed the basics.
So, to wrap this all up, I'm going to leave you with one final question to think about. Right now, this very second, what 2 types of waves are you using to see and to hear this explainer? It's light waves, which are transverse, that are letting you see the screen, and it's sound waves, which are longitudinal, that are letting you hear my voice. How cool is that? You're literally experiencing both types of waves right now.
Fantastic work today, everyone. You really nailed the basics of waves. Now, the best way to really make all this new knowledge stick is to go try some practice questions yourself. Thanks for joining me, and as always, keep that curiosity going.